Okay, good day, grade 8 Makati Science High School students. For our second module for the third quarter, we're going to be discussing about areas of triangles, and also let's try to have a very brief introduction to the law of sines and cosines. We're going to be discussing this topic in the in the last parts of our third quarter, but let's just have a very brief discussion on it and how you can use the formulas regarding the laws of sines and cosines. Okay, and of course, the areas of a triangle. So for this problem, we have our first problem here. Melody and Nicholas wanted to create the perfect logo for their math lovers club. Reflected on the figure below is the logo and its labels. Given that the radius is equal to 10 centimeters and okay, that's the only given for this one, the radius is equal to 10 cm. We need to find the measurement of angle AOC, the length of OD, the length of BD, and the area of triangle ABC. Okay, so let's try to solve first for the measurement of angle AOC. So AOC is a central angle, okay? And we have here a radius of 10, okay? And we've created this triangle from this radius. Okay, so if we're going to draw a circle here, we can divide this triangle ABC, into three congruent isosceles triangles. Okay, so why are there isosceles triangles? All of the radius are congruent to each other. All of the radii are congruent to each other. So therefore, for this one, we can say that the measurement of AOC is just going to be 360 divided by 3. So therefore, the measurement of angle AOC is just equal to 120 degrees. And that's our first important clue. If this is 120 degrees at the center, if we're going to draw a perpendicular bisector here, like what we did on this figure, so if this is 120 degrees and this is 90, so therefore this must be 60 degrees and this must be 30. Okay, so this must be 30 degrees for this one. Okay guys, so this must be 60 and this must be 30 degrees. Okay, so for this problem, if we have here a 30, 60, 90 triangle for this one, then therefore we can say that since this value here is equal to 10, okay, since the hypotenuse is equal to 10, we can equate that with 2s, or with 2 times the side measurement using the 30, 60, 90 formula. If you guys remember, okay, using our previous theorems on special right triangles, 30 is equal to s, 60 is equal to s squared of 3, and 90 is equal to 2s. And since we know that 10 is equal to 2s, we can divide both sides by 2, so therefore s is just equal to 5 units. Okay, and the 5 units, that's gonna be the height of the small triangle here, of triangle AOC. Okay, so that's gonna be the height of this triangle, so that's 5, and therefore we found the measurement of OD, that's equal to 5 units for that one. Okay, and for this one, we have here, so this is going to be s squared of 3, and since we know the value of s is equal to 5, therefore the side measurement here, that's going to be 5 squared of 3. Okay, and to get the base of this triangle, that's just going to be multiplied to 2, and what's 5 squared of 3 times 2? That's going to give us 10 squared of 3, and that's going to be the base of our triangle for this problem. Okay, so if the base is equal to 10 squared of 3 for this one, okay, then we can get the height of this one, of OB. Okay, so what's the measurement of OB? Since that's the radius of the circle, that's also going to be equal to 10 as well. And we know that BD is equal to OB, or BO, plus OD. And since we know the value of OD is equal to 5, and we know that the value of BO is equal to 10, or OB is equal to 10. So therefore, that's going to give us 15. Okay, so therefore, the height, guys, of the triangle is equal to 15 units. And now, we can use the formula for finding the area of a triangle to solve for the area of triangle ABC. This is our main question for this problem. Okay, so for this problem, this is going to give us 1/2 times the base, and we've already solved for the base, that's 10 squared of 3. Okay, so this is going to give us, okay, 10 squared of 3 times the height. And what's the value of the height? We already solved for that a while ago. It's not 5. That's the height of the small triangle. The height of the big triangle of triangle ABC is equal to 15. Okay, so for this one, this cancels out. This is gonna give us 5 square root of 3 times 15. And what's 5 square root of 3 times 15? So what's 15 times 5? So that should give you around 75. 75 square root of 3 squared units. And there you go. We found the area of triangle ABC. It's just equal to 75 square root of 3 squared units for this problem. We also found the measurement of angle AOC, 120 degrees. OD is equal to 5 units. And BD, the height of the triangle, is equal to 15 units. And this is again the area. 75 square root of 3 squared units. And that's how we solved it.